A 5-story wound of deep crimson liquid pours from white Antarctic ice right now. It never freezes, it never stops. Same red every record for as long as anyone watched. For over 100 years, nobody could say what the red was, or where it came from. Back in 1911, a geologist mapping a frozen valley stumbled straight onto the crimson stain. He named it Blood Falls, and guessed red algae living in the ice caused it. The falls sit at the snout of Taylor Glacier, one of Earth's driest places. These valleys are so cold and arid, almost nothing here should ever be liquid. So a never-freezing red stream here is on its face a flat-out impossibility. But the algae theory hit a wall. Researchers tested the water and found 0 red algae, and just like that, the first explanation collapsed. The color got even more mysterious. To crack it, scientists faced a weirder question first. Why is this water liquid at all? In ice this far below freezing, flowing water demands a hidden source, heat or chemistry. The first clue was the chemistry. This outflow was extraordinarily salty, far saltier than seawater. Salt slashes water's freezing point. Heavy brine stays liquid where pure water locks solid. That ruled out surface melt. This was briny water rising from somewhere buried below. So where could a pool of super salty water hide beneath a glacier in a frozen desert? To find that pool, we have to rewind millions of years before any ice existed here. Around 5 million years ago, the ocean flooded this region, then got completely sealed off. Then the climate froze. A growing glacier crept over the seawater and trapped it underneath. Since then, that buried lake has sat in total darkness. No air, no sunlight, ever. Slow freezing kept squeezing out fresh water, concentrating the rest into brine, triple the ocean's saltiness. Here is the hidden reservoir feeding Blood Falls, but it still doesn't explain the color. With 0 oxygen down there, this brine should be a chemical dead zone. Lifeless. Dead. Instead, scientists found it teeming with microbes, alive in the dark for millions of years. No sunlight, no oxygen, so these microbes can't photosynthesize and they can't breathe like us. So how do they survive? They pull energy straight from the rock, cycling sulfur and iron. The bedrock beneath the glacier is loaded with iron, which the brine slowly dissolves. Now that water is loaded with dissolved iron, yet down there it stays perfectly clear. The glacier above never stops moving. Its weight squeezes the brine toward a crack at the edge. Inch by inch, this ancient water is forced upward through fissures, climbing toward the surface. Using radar, researchers image the plumbing, a tangled network of channels threading the glacier. And the salty brine makes its own heat as it freezes, keeping its escape path open. So the falls never seal shut. The brine carves its own escape, freezing just enough to stay open. Then the brine reaches open air at Blood Falls, and instantly, something changes. For millions of years, that iron never touched oxygen. Now, at the surface, it finally does. It's the very same chemistry that turns a forgotten nail orange after rain. The dissolved iron grabs onto oxygen the very instant it hits open air. And the iron oxidizes into rust, staining the brine blood red the instant it meets the sky. That rust is the blood. So Blood Falls isn't bleeding at all. It's rusting in real time as it pours. This crimson is an ancient ocean exhaling iron after 5 million years sealed in darkness. And those survivor microbes, they're now a model for life beneath the ice of Europa or Mars. What looked like a horror became one of the most isolated living ecosystems ever found. And it's still flowing today, leaking a frozen chapter of Earth's deep past onto fresh snow. Antarctica keeps stitching its strangest secrets into the ice. Somewhere, another one is waiting to bleed through. Go find it.